Well, hey guys, You Water with Scotty here. We're down in my basement fixing my water heater. This video is, in a nutshell, it's going to be about replacing hot water elements in a hot water tank, but it is really going to be much more than that. There are plenty of videos on YouTube showing you how to change the hot water element in a water heater. That's fine, but this one is going to be slightly different. This one is going to get pretty interesting. There are a lot of weird things that were happening here. I hope you stick around for the full video because there are a lot of interesting aspects that we learn in this video. So I will see you soon. Well, hey guys, You Water with Scotty coming at you here. I got an interesting problem for you today. I'm kind of playing a little bit of a detective. There's been weird electrical noises happening in my house. They're coming from the breaker panel. Sort of like a 60 cycle arcing kind of a sound. Bit of a mystery here, so we'll go look at the panel and see if we could see anything that's going on. I've only heard it once. Jayla's heard it 2 or 3 times. But yeah, right in the laundry room here where the panel is, has been making some arcing noises in here. Now I've got the sort of the front panel off. I kind of learned a few curious things about my electrical system already just by getting in here. Number one, this panel, for whatever reason, is actually installed upside down. Also, I've discovered that my house is not earth grounded properly, so we're gonna have to do that in a separate video. And we've got this wire sticking out here. There was going to be 240 installed in the garage, so I think that's where that's going. Now the arcing sound, I wasn't sure which breaker it was coming from. The water heater circuit is this one right here. You can see it's disconnected right now. And this was where the arcing sound was coming from. So this side of it, this 30 amp breaker seems okay, feels okay, but this side seemed worn out. So I thought initially this could be the breaker. Alright, gotta turn the master breaker off here. Got to take this guy out. And on closer inspection of this breaker, you can see that one of the blades here is all burned up. The other one's okay. One of them's all burned up there, and that happens to be the one that feels weird. We're inspecting the sort of blades of the breaker panel. I thought it was the breaker. I thought this breaker was just worn out, and it's consistent with, it's old. This doesn't really feel very good, and also this connection here. Oh no, it's actually the other one. Why did I miss that? My initial inspection. Okay, well anyways, this breaker is old and doesn't feel very good. So initially I thought, okay, we got some arcing in the panel here. This breaker seems like it's on its last legs. I mean, that really does not feel very good at all. It doesn't even feel like it's engaging, or that's something wrong with that. So went to Home Depot, got 2 brand new breakers, and that feels much better. I'm not sure about this spot in the panel because I don't really like the way that blade looks there, and that connection, sorry. So I just moved up to a new spot and I had a blank spot here, so I put a new breaker in here, but then the wires were not long enough to reach up here, so I actually just put these extenders in here, which is probably not super up to code, but hey, seems more or less safe to me. So right now this is the breaker, the new breaker for the new water heater, and I do want to check that out because when I put this breaker in and turn it on, it was fine. The water heater fired up and it was fine for about an hour, and then it did the arcing noise again. So let's take this breaker out and see what that looks like. Alright, now we got this breaker out. Inspecting it. Feels okay. This is a brand new breaker for the water heater. And the sort of the blades on this look good. So no damage there. And the connections where this go looks okay too. And I think maybe I'm just seeing things. Oh, maybe not though. Does look like this is damaged a bit, so yeah, that one there doesn't look too good. Looks like it burned up. Oh yeah, she's burned up. See, definitely some arcing going on there. Seen better days, that one there. So we're not going to put a breaker back in there. So we're on a brand new spot up here. Alright, that's good right there. Again. Yeah, seems good. Main power. Okay, this is still off. So the water heater circuit is still off. So, still get that arcing here, even with that new breaker. So let's go downstairs and... Alright, so we replaced the breaker in the panel. And that's doesn't seem to have done anything to fix the problem. So when I switched that breaker back on, what happened was everything worked well. The water heater fired up and everything worked well for about an hour, and then that arcing noise came back. So, which tells me, or told me, that it wasn't the breaker. The breaker wasn't worn out. Man, keep in mind, this is a brand new water heater, so at this point I'm very confused. I'm trying to speak in the present tense, but really we're in the past tense here. I already know what the problem is, but I'm trying to kind of lead you guys through the mystery, because I was very stumped on this for about a week. Let's have a look at a specific wiring diagram for my water heater. Alright, having a look at the wiring diagram here, and once again, this is a brand new water heater, so I'm not at this point I'm not suspecting anything wrong with the water heater. But having a look at this wiring diagram of how this works, let's have a look here. The 240 comes in here, and we've got this upper thermostat high temperature limit switch, which is essentially, if I understand it correctly, just a little tiddlywink that pops itself off if it gets too hot. So these are usually always on unless it gets too hot. Two sides of the 240 come down here. We connect to pin 1 of the upper thermostat for the red. Connects through here and connects directly to the upper element and the lower element. We see this kind of interlocked system here, which either connects the top element or the bottom element here through the lower thermostat. So these two elements are never on at the same time. It's always the top element first and then the bottom element. So I didn't really know that. So, and I believe the reason for that is so that you get the water in the top of the tank hot first, because that's the water you're going to use first. So heats that up first, and then once that's hot, and if it's not being used, then it comes down here. The lower thermostat is usually always this on, because the water in the bottom of the tank is colder with the dip tube. If this is the tank here, we've got a dip tube that comes in and sends the cold water down to the bottom of the tank. So, hot water rises, cold water sits at the bottom, and that temperature gradient is pretty intense. Like the water really doesn't mix. So it's interesting how that works, that temperature gradient. But you can see here, top element turns on. Once it's hot up here in the top of the tank, then this is going to flip this over to pin 4, and that's going to energize the lower thermostat, which is on because the water down here is cold. The lower heater comes on. Once everything's hot down here, then the lower thermostat is going to kick off, and we've got both the heating elements off then. So it's interesting how this works. They're never on at the same time. It all has to do with this little interlock switch here, the upper thermostat. So that's something that I didn't know, but is definitely pretty crucial to this mystery of arcing noises coming from the panel. So my theory at this point is that there may be a problem with the lower element in the water heater, because what's happening is I could turn the panel on and the water heater turns on. I can hear it starting to heat the water up, but after an hour you get that arcing noise in the panel, and that would be consistent with that little interlock system turning to the lower element. And yeah, that's the only thing that I can think of that would make sense of why, you turn the power on in the panel and it's fine for an hour, but then all of a sudden it starts making arcing noises. So I'm suspecting that lower element there. So what we need to do now is go test the elements in the water heater to verify that that is the case. So let's go do that right now. All right, here we are at the water heater. As you can see, it's a newer water heater, and you can see I've already started doing stuff to this. So I believe that I have pinpointed the problem, but let's just have a look here. So here's this top thermostat. How does this come out? There we go. It's right in the way. Get this one out of here too. Just these little tabs here that are meant to be broken off. Anyways, here we see the tank, brand new, newish tank, well, within the last 8 months. Alright, so here's our water heater. Like I said, I just put this in, but I'd say maybe maximum 8 months ago. You can see 240 comes in here, and this red and black wire. We've got our over limit switch here, and we've got this, we've got one side of the upper and lower element energized with these two wires. So blue wire comes down, energizes, connects to one of these screws, and then we've got another red wire that comes all the way down the tank, comes down to the lower element and connects on here. And we've got a thermostat down here that either switches this lower element on or off. Here's your sort of interconnect system, and then the other side of the 240 is either energizing this or that. And when it's energizing this, it's got the top element on. Once this thermostat kicks off, it kicks it over to this lead here, this black wire, which then comes down and energizes the bottom element here, and then once that's hot enough, they're both off. So yeah, so that's how that works. And the next step to see if this bottom element is working properly is let's measure this element and see what the resistance rating is here. But before we do that, we can look carefully at this lower element here. And here's another clue. you look really carefully, you see there's some water hanging out there. It's not a lot, but it's just a little bit. See if we can't get some light on that. If you look carefully, you'll see there is some water hanging out down there. So this element down here is leaking, which is sort of curious. It's not a lot of water, but it definitely is leaking. So let's move this out of the way. Let's see that it is leaking. And if we look extra close, we can also see that, yeah, so anyways, this element is leaking, and that gives me another clue. So there's something wrong with that element down there. So let's continue our testing here. The first thing we can do is we will test for continuity on this heating element here. So, alright, so that's good. Let's actually measure the ohm reading resistance here. .5 ohms. Now I'll go and do the same with the bottom element. Maybe down here we'll check the resistance first. Well, there's something wrong because these two elements don't match. This is roughly 6.2 k ohms. So there's a lot of resistance there for one. And if we test continuity, we see that it is essentially open. It's reading as a diode right now. So the voltmeter thinks it's a diode, which is not right. That should be have a good clean connection there. Plus the fact that it is leaking, so that makes me believe that that lower element is not good anymore, which is weird because this is a brand new water heater. Now, conveniently in my house, I have two water heaters that I've replaced them both within the last year. So we can actually have a look at this bottom element on this other tank, which is identical to the tank in question, just to verify that I'm not just making this stuff up. Go to test continuity of this bottom element here. So we have continuity, and then we'll check the ohm reading. And we have a reading of 18.5, 18.4, and the element on the other side was 19.5, so it's within the same range. So that tells me pretty certainly that that bottom heating element tells me pretty certainly that that bottom heating element is done. So this is the exact same water heater, and you've probably seen me put this in actually, and there's this pump that I put in a previous YouTube video, and replaced all the plumbing, and everything's going good with this pump, by the way, not to get sidetracked, except we do have a little leak starting to happen around just around this pressure sensor here. This is It's starting to leak there. And I will deal with that. We will, in another YouTube video, replace that fitting, because you never want to let this stuff go. You let this stuff go and it turns into a bigger problem. So I always want to get this dealt with right away. But anyways, this pump is running really nice, no leaks, nothing like that. And anyway, so we'll deal with that in another video. Let's head on over to the other side of the house there and deal with this water tank element, which seems to be bad. So let's deal with that. Alright, so I think it's safe to say that lower heating element has gone bad, which is really weird because it's a bad, like I say, I would have thought it would last longer than that. But we do have pretty bad water here. So I've got two heating elements, two styles, the 3000 watt, 240 volt screw in, and it's got that little gasket there. This one sort of folds over on itself. I don't really know what's in the tank. I've got this giant one. Again, it's 3000 watt, 240 volt, same kind of style, screw in. This one's longer. I think that's probably more consistent with what's there already. And then of course I've got a water heater element removal tool. Element wrench is what they call it. I've seen some people sort of hydrolock the tank. So you see I've got both the valves going into the tank turned off, which presumably hydrolocks the tank. And I've seen a lot of people online just sort of unscrew that, pull it out, and put a new one in really quickly. And you know, there's water sort of coming out of the tank even though it's hydrolocked. But I don't really feel like getting water everywhere, so I'm going to put a towel down and just use the pressure relief valve here to let air in the tank. And I'm going to drain most of the tank because yeah, I just don't feel like rushing this or getting water everywhere. Right here's the setup. I just got a hose coming to this drain valve, and then I'm going to open this, which makes it so that water can flow through the hose. Of course, there's a little coming out of the pressure relief tube here as well. Just fill that up and dump it out. It's going to take a lot of buckets. I got some time here, not in too much of a rush, so just keep doing that until probably it's going to be like 50 buckets in there. Well, we'll keep doing this until we can't do this anymore, and we'll see you very shortly. Got dueling buckets going on here. This is going to take a while. 39 gallons worth. I feel like getting water everywhere though, you know? Some people do that. They take that out and with the hot change thing, there's water pouring out. I don't like that. I got this just plywood floor here. That means that we started getting to the top of the Eventually no water will come through this tube. I think we've reached that point. Okay, I don't know, this is bucket 10, I think. I think this is bucket 10. A couple more to go, I think. There's another advantage why I'm actually liking draining the whole tank, is I'm having a look at the water as it's coming out. which is sort of helpful because, you know, lets me know if there's a lot of sediment in the tank or what. So I'm pretty happy about that. So that's an added bonus. Here's something kind of interesting. You sort of see how much water is left in the tank here by looking at the level. So it's about 3/4 of the way down, I guess. So it's sort of an interesting way of telling how much water there is left in the tank. Just using this dish to get the water down below where the heating element is. And right now, we're almost there. Almost there. Almost there. Pretty close. It's not flowing anymore. Gotta use this dish to get below the heating element now. Right at this point we're well below the heating element, but I'm gonna go all the way here because I kind of want to see what's in the bottom of this tank, how much sediment buildup we've had in this short time. Doesn't look too bad. You see definitely some sediment here. That's the first I've seen. It's really not all that bad, and we're really at the bottom of the tank now, because even when I lift this hose up, even slightly, it stops draining. So so there's a tiny bit of sediment, but definitely not too much. So that's good. It's good to know. It's good to know here. So I'm pleased about that. Alright. Definitely some sediment here. I can crack the drain like this now. Almost nothing left in the tank. Not sure how this works. Oh, okay. Oh, I see. Well, very little sediment in this tank, so that's really good news. It's completely empty at this point. I was expecting a lot more than that, actually. So I was wondering how that worked. Anyways, I think we're good. Put this back on. Okay. Right now this tank's completely empty. We should be able to go ahead and unscrew this element here. Okay. Here we go. We got this tool here. Got a Phillips head screwdriver. Just to put it through here. Okay, it fits, so that's good. And well, it goes off pretty easy. So we shouldn't get any water come through here. Oh wow. Okay. Yeah, that'll, ooh, wow, that'll do her. Jeez. Holy jeez. Wow. That, yeah, that is not going to work. Ooh. Holy jeez. Oh God, I wonder what the top one's like. Well, we should take out the top one and see what the top one looks like. Alright guys, this video just got really interesting. First of all, I'm really happy with the way this is going. Also, we've learned something in this mystery. It's very, very interesting. So with the condition of that element down there, I'm now not super confident in the element up here. Let's take this one out since we got the water heater all drained out now. If we hadn't have done that, if we hadn't have drained the whole tank, we wouldn't have had that option. So let's take this element out and check on the condition of that, because that's probably pretty on its way out as well. I bet you this one's screwed up too. I'm really happy I bought two today. Alright, what do you think, guys? What do you think this one's gonna look like? Oh, this one's not too bad. This one's not too bad. Interesting. Let's have a look at this guy here. This one's not too bad. It's got a little bit of scaling on it, but definitely nowhere near as bad as the other one we just took out. I wonder if that one's still good to be put back in or not. This one looks okay, but I'm not sure. We should just go ahead and replace that one too. That looks a little strange here, doesn't it? Let's wipe this off. This one does look copper. This one looks okay. I don't see a problem with this one. Maybe we'll just put this one back in, but I don't know. Since we got it all drained out, maybe we'd I think maybe we should put I don't know. Can't really decide. Boy, I'm ever glad that we drained that tank. This is the proper way to do it right here. Let's examine this. This one still looks good, but I mean, it's the same type of heating element that was in the bottom. I don't know if these elements here are better or worse. I've got this one here, which is a big long one. I wonder if that's higher quality. This one's probably higher quality. I don't know. I really don't know. And then I've got this one here. And that one there is a different style of a heating element. Let's check this out. Alright, let's do some analysis here. Here we have the two elements that came out of the water heater. This is a Rheem water heater. I'll admit it's not the deluxe model, the most expensive model, but still thought that these elements would have lasted a little longer. Let's have a look at the good one. There's some sort of, I don't know, like kind of a protective sheathing here and a copper tube. If we look at the one that's broken and examined this pretty closely, you can see actually that sheathing is just cracked. The tube is cracked. It is warped. And we could see that the actual element inside is some kind of just a wire wound resistor type element inside this copper tube, which is ruptured in several places. Actually just broke right off there. So interesting. So now we know sort of a little bit about how these are made. I think copper, I'm sorry, I'll try and make a decision whether or not to put this one back in, but I think I've made up my mind. I'm not going to, because if we look at these just kind of look, they're definitely a bit beefier. You know, the element itself is just a bit beefier, as well as I believe that's a nickel, maybe a nickel. I'm not exactly sure what kind of coating or tubing that is, but it looks like maybe nickel, which seems to be like it would be a little bit more inert in that hard water environment. But I'm definitely going to give these guys a try, just because obviously the copper ain't working out too well. Which makes sense, because this water really eats at my copper pipes, so I get pinhole leaks all the time in my copper pipes. So probably having copper heating elements doesn't help, and that's quite dramatic. It is quite dramatic. All right. Let's go ahead. I think we've made up our minds here. Let's go ahead and put these two bad boys in. These look like they'll do the trick. Maybe I'll put this one up top and this little guy down at the bottom. These are both rated 3000 watt, just like the other ones were. And I'm very happy I brought two of these today. And the guy at the hardware store said it doesn't matter, that it's just a different design, but it should work just the same. So that's good. Let's get back over here to our water heater, get you guys set up on the tripod. We'll put this big old girl up top here and the small one down the bottom. Nice little water heater upgrade. Alright, so one of the things that happened that was very curious when I first started diagnosing or trying to figure out what was going on here. Now keep in mind, I thought it was something to do with the breaker. It wasn't. We know now it wasn't. The other thing, I mean, this is a brand new water tank. It's like 8 months old, so I really didn't think it was a water tank. But what I will say, something that I noticed when I took off this sort of junction right here, something really weird happened when I took this apart. This, of course, we got our 240 on each side, red and black coming in here, and then of course we've got our grounding wire. Now I don't call that a ground, I call that a bonding wire, and I'm going to tell you guys in another YouTube video why I call that a bonding wire. But something that happened, which was weird, was I touched this plate, just happened to be putting this back together, and I touched the plate to the tank here, and I got a spark between the body of the tank. Of course, this is all grounded and connected to the tank, and this plate here, which that should never be. That doesn't make any sense. So yeah, I just could not figure out why there would be voltage between here, the grounding wire here, and the body of the tank. There should never be any voltage there, but it was literally sparking, and it was a considerable amount of energy there, and I just could not, that just did not make sense. But of course now after seeing the condition of the heating element, we've now solved the mystery of why that was happening. Let's get the heating element down here and let's have a look. Alright, so this is a very, very dangerous situation if you think about it. We've got a heating element here. It's broken, but it's still connected to mains power. So essentially what you have, this is still in the tank. This is basically, well, both sides of the 240 line sticking into the water in the tank. And as you know, my water that I have here is very corrosive. It's very electrolytic. It's an electrolyte. It's got lots of dissolved minerals and all kinds of ions and just who knows what in my water. It's really bad. As you can see, that's what it does to heating elements. And my copper pipes will have to all be replaced here. So yeah, you got both sides of the 240 line into the tank and making contact with water that is extremely conductive, more so than, you know, regular rainwater or whatever. And that water is touching the side of the tank, and the tank is bonded. Now I say bonded, I don't say grounded, I say bonded, and that's an important distinction, and we're going to talk about that in another YouTube video. But essentially this wire here, this equipment bonding wire here, is connected to the tank. So essentially what you have is current running into the tank through the water to the body of the tank, hooking to this bonding wire running all the way back to the breaker panel. And inside the breaker panel, that grounding or bonding wire is hooked to the neutral. So essentially you've got a circuit here. You've got a circuit with a busted heating element that can create several really dangerous situations. First of all, you're basically doing electrolysis with the water, so that's never a good thing. Get a lot of harmful gases and things like that. So you can even get like hydrogen gas forming in there. So that's really not good. That's very dangerous. And then the other thing too is that the body of the tank is actually energized. So if I was to touch the tank and then, I don't know, touch something else that was grounded back to the panel, or even just if I was in my bare feet standing on the ground, I would get a very nasty shock. So the tank, this being this situation here, the tank is actually energized, which is a very interesting thing. I had no idea why I had voltage there on the tank going back to the panel. But that you gotta remember that neutral and that bonding wire, they are connected in the panel. And that is so that if any of your equipment, anything that's plugged in is ever, if one of those hot wires were to come loose and energize the chassis, that would be the thing that would provide a low impedance path back to the breaker, and it would trip the breaker. Now, didn't trip the breaker because there's also a considerable amount of resistance through the water. So we do have current flow, but it's not enough to trip the breaker, which makes perfect sense now, because I was getting that arcing noise, that 60 cycle noise, and it didn't trip the breaker. So we probably didn't have enough current flow to trip the breaker, but still a very dangerous situation. And now if you don't understand why this is dangerous, I will talk about this exact situation in another YouTube video. For now, let's concentrate on the tank and getting the heating elements back in the tank, getting things all buttoned down. But this is a very eye-opening experience for me, and yeah, is a very interesting. Very, very interesting. So we've got several sort of dangerous things happening here. Anyways, let's get back to this. Something that was very interesting. I'm very happy to find out why I had voltage there. I could not figure it out. Why I would have voltage on the tank like that. Anyways, pretty interesting. Let's... Didn't like the way that went in, so I'm gonna toss a little oil. These threads can't hurt. Just doesn't feel very... There we go. There we go. That feels better. Yeah, way better. Way better. Okay. Okay, that feels good. Confident with that. Doesn't have to be super tight, but it's snug. Snug it up. If it leaks, we'll just put a little tighter. There's our new heating element installed. A little bit of oil on the threads, non-toxic oil. Everything nice and tight. Tighten up all the other connections. It's looking good. Let's go down to our bottom element here. Do the same thing. I'll put some oil on the threads. There we got another heating element here. We'll put some. Seemed to help out. The oil seemed to help out on the last one, so. Okay, got it. This is Inspector Zoe. This Inspector Zoe we have here. Zoe. Inspector Zoe. Is everything going well here? Is this up to code? Finding some code violations here. You don't see enough treats around. There's no treats. Should be some treats behind the water heater. I'm not seeing any treats. There's a violation number 1. Okay, I'm sorry I said the T word. Zoe's doing good. You're doing good. Go Dodos. Go Dodos. Daddy's trying to get the hot water working again so you can have a bath. So you can have a bath. Hey? Yo. Who's a good girl, Zozos? Zozos? Who's a good girl? Alright. Hey? Zoe. Who's a good girl? Okay. Alright, we got Zoe here. Tighten this down. Are you inspecting? You're inspecting everything. What are you doing? You're inspecting. Alright. There's not enough room for us, 2 of us down here. Okay. I gotta get back to fixing the water heater, okay? Okay, we'll go upstairs in a sec. Okay, we will. Alright, just give me a sec here. I gotta fix this. Okay, gotta move. Move. Go on. Go on. Go on. Okay. Very important to remember to put that down. Super important. So, we should probably reconnect this too. Let's do that before we put the breaker on, just to make sure that if we do have any problems with the tank being energized, we have a proper ground here. Alright, that's all buttoned down. We can, I suppose, start filling the tank up. So, that's cold. And, oh, jeez, this needs to. I should probably open a faucet upstairs. Let's do that. Open a faucet before we do this. I think. Oh, let's do that. What do you think, Zoe? You should go. It's time for you to go upstairs, I think. Come on. Come on. What do you think? Huh? Come on, let's go. Okay. Can you make it through? Let's go. Let's see you go. Wow, good job. Okay, you want to lie there? That's cool. I gotta go upstairs and turn on the water now. Okay. Who's Daddy's girl? Huh? Good girl. I think you should come upstairs. Want to come upstairs? Come on. Come on. She was having some problems with her back leg there the other day, and seems to have took her to the vet, and that seems to have fixed it up. We got her on some omega-3 fish oil. Ho 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 ho. Got her on some omega-3 fish oil, and got her blood tested and everything like that. Don't tell mommy. Don't tell mommy. Don't tell mommy. Okay. All right. Let's open hot water. Just don't want to actually. Let's open this hot water too. All right, now let's open. We'll check for leaks. Hopefully no issues. Anything was gonna leak, it'd be down here first. Nothing there. Okay, should be mainly air coming out upstairs. Should be mainly air coming out. Can hear it, so that's a good sign. Okay, that's good. Beautiful. So nice, so nice. Okay. Okay. Okay, it's looking good. Hopefully we don't got no leaks. Very good here. So there's some cavitation maybe. Doing okay down here. So far so good. No leaks down here. Very happy about that. I don't think we're up here just yet, so all of this is going to have to get replaced. While we're waiting for this to fill up, you have a look over here. My panel is grounded to this copper pipe. But this copper pipe does not have a earth ground anywhere. As a matter of fact, it is not connected anywhere to earth ground even before I changed this to PEX. So yeah, that's something that has to get fixed really quick. If we get a lightning strike or anything like this, all of this metal in the house is going to start arcing. So we have to get a ground rod. I wonder if I could just drive a ground rod just down in here. I'd rather do it outside. It's probably better to have it done outside, but oh, what are you up to? You waiting for Daddy? You want more? You want more food, don't you? I know what you want. Still air. Still air. Not quite yet. Okay. No. You had your dinner. Still air here too. Okay, that's gonna take a while to fill up. That's all right. Whoop. Looks like we might have our tank full up. Let's see. See what we got. We got hot water. We got water coming out here, so that's a little screwed up. Okay. I think we're ready. I think the tank is full. I think it's full now. So we can go ahead and probably turn on the power. Just check one more time for leaks down here. seems good. No leaks here. No leaks down there. Okay, so got a full tank of water. Let's fire on the power. Alright, here is the moment of truth. So our new breaker is right here, so let's fire it on. We're now on. Let's go check, see if we can hear any heating happening. I do not hear anything though. I've got 240 volts there. I just measured it. Usually you can hear the water heating, a little sizzle. I don't really hear that. Maybe, I don't know. Don't really know why that would be, but just going to be patient. I'm going to give it an hour and we'll see what we got. Okay, kitchen's a little messy, but guess what? We'll finally be able to get some hot water, do some dishes here. Happy ending to this video. I don't know, those new elements must be just super quiet. I can't even hear them working, but we do have hot water. Okay, it's nice and hot. Now she's hot. Ooh, super hot. Right on. Okay. Well, hot water, folks, and wonderful, happy ending to this video here. So that was a very interesting little troubleshooting session we had there. Pretty happy the way that turned out. Learned a lot, and so I think what I'll do now is we'll wrap this video up, and stay tuned because I'm going to do a little spin-off video of this one, and we're going to talk about I think we're going to talk about grounding, because that seems to be a topic that everybody's really confused about. I've been doing a lot of reading about it, but grounding, bonding, and earthing, we'll talk about all that stuff in the next video. So stay tuned, UAutoScotty. We'll see you soon.